Hello everybody, today we are going to be doing another differential equation, but today we're going to be doing something called a Bernoulli differential equation, okay? That's Bernoulli, spelt like this, I think. So Bernoulli is what we're going to be doing today. So, solution. So first of all, we're going to divide out by this power of y to the fourth. So when dividing by this, I'm just going to write, by the way, I'm going to make use of this notation today, okay? I'm going to be saying derivatives, I'm going to be using the prime notation, alright, just to clarify. So dividing out by this, we get y to the minus 4, okay, I'm going to write it like that, y to the minus 4, y prime plus 1/3, and it's going to be y to the first power divided by y to the 4, so it's going to be y to the 1 minus 4, so it's going to be y to the minus 3 equals e to the x. Okay, very nice. And now we're going to make use of a substitution. We're going to say let v equal y to the minus 3. Okay, this is what you do in Bernoulli's. You make a substitution, and now you'll see why in a moment. So then, actually, let's just write this as v prime. So derivative of v is just going to be minus 3 y to the minus 4, and then of course multiply by y prime. Okay, this is the chain rule. Okay, so now we've got this, and we've got this. Very nice. But now notice that here we have a y to the minus 4 y prime, and we've got that here. That's really nice. But we've also got this negative 3. So we're going to get rid of this. We're going to say, well, negative 1/3 of v prime equals y to the minus 4 y prime, and now we can just substitute these in. So we get y to the minus 4 y prime, that's going to be negative 1/3 of v prime. Y to the minus 3 is v, so it's going to be plus 1/3 of v, and then e to the x. Okay, very nice. Now we don't want a coefficient on here, okay, because we want to get it in our general form for the integrating factor. So we're going to multiply out by minus 3, giving us v prime minus 3v equals negative 3 e to the x. Now from here, we can notice that our integrating factor r of x is just going to be e to the integral of p of x, which is negative 3. You've got to remember the minus sign here, that is pivotal, okay? So it's going to be minus 3 dx, which equals e to the minus 3x. Okay, so yeah. Oh no, sorry, made a mistake here. This is just really sorry about that. That's really silly of me. There's not a 3 here, because we multiplied that by the minus 3, so the 3 would cancel with the 1/3, so we just get minus 1v. So it's going to be e to the integral of negative 1 dx, which equals e to the minus x. Okay, so that is our integrating factor, r of x. Sorry for that little mistake there, but it's okay, we're on the right track now. Now, of course, we're going to multiply out by e to the minus x. So we get e to the minus x, v prime, then it's going to be minus e to the minus x, v equals negative 3. And now e to the x and e to the minus x, well, we'll add the powers, so it's x minus x, which is 0, anything to the 0 is 1, so we just get minus 3. Very nice. Now notice that this is none other than the derivative of the product v and e to the minus x. We can verify this. If we take the derivative of this, we get v prime, we leave this function, so it's going to be v prime e to the minus x, plus, we leave this function, and we get v minus e to the minus x, so we get minus e to the minus xv. Okay, so we know that's right. And this equals minus 3. And now we can simply take the integral, with respect to x. That's a minus sign. And now we're going to get that, we're going to get some nice cancellation here. We get that v times e to the minus x equals negative 3x plus c. So let's write this as c minus 3x, just because it's just a bit nicer, okay? It's going to be c minus 3x. V equals, multiply out by e to the x, divide by e to the minus x, so multiplying by e to the x, we get e to the x, c minus 3x. So v, which is 1 over y cubed, equals e to the x times c minus 3x, and that is our solution. Okay, we don't need to solve for y here, it's just unnecessary, we can leave it in the implicit form. So yeah, that is our differential equation today, and that was our solution. It's quite nice. This was a Bernoulli differential equation. It involved a bit of substitution. It made use of the integrating fact we did last video. So yeah, hope you enjoyed the video today. Maybe you learned something new. And yeah, goodbye.